In this example, we want to find the values of the 6 trigonometric functions for angle B if side B is equal to 8 units and C is equal to 11 units. So the first thing we could do here is draw a diagram. This example is referring to a right triangle, and we always make the right angle angle C, and then your other two angles are A and B. It doesn't really matter which one you label which. Now, we're told that side B, so side B you should always set up opposite of angle B. So here's side B. We're told that the measure, or the length of that side is 8 units. And the length of side C, which we need to make sure we set it up opposite of angle C, is 11 units. If you have the lengths of all 3 sides of a right triangle, then we can generate any trig value we want for the angles within that triangle. Or for the acute angles, I should say. In this case, A and B. So the first thing we want to do is solve for the missing side. Notice I said if we have all the lengths of all 3 sides, then we can find whatever trig values we want. And so if you have the side lengths for 2 sides of a right triangle, then we can use the Pythagorean Theorem, which says a squared plus b squared equals c squared, to solve for the missing side. So in this case, A is our unknown, B we know is 8, C is 11. So A squared plus 64 equals 121. And so A squared is equal to 57, yeah. A is the length of a side, so we should take the positive root. Take the square root of both sides. We take the positive root as our length for side A. So now we have A is equal to the square root of 57. Now we can start cranking out values of the trig functions. I'll start with sine. And we were asked to evaluate at angle B. So sine of B, I'm going to use the old SOHCAHTOA way of remembering what's what. So sine of B, here's B, is equal to the length of the opposite side over hypotenuse. That's the SO part of SOHCAHTOA. So in this case, opposite of B is 8 over hypotenuse is 11. And we could have actually found that value without solving for A. All right, that's sine of B. Cosine of B, so that's the ca part of SOHCAHTOA. Cosine is adjacent over hypotenuse. And again, make sure you're when you're finding, what's opposite, what's adjacent, we need to refer to the angle B. That's relative to B. So in this case, the side adjacent to B is this side. I realize there are 2 sides that are actually adjacent to B, but hypotenuse, the one that's opposite of the right angle, has its own distinction there. So relative to B, this is the adjacent side right here. So we would do adjacent over hypotenuse. And there's your answer for cosine of B. Here's our answer for sine of B. Okay, we could do tangent. I'm thinking about what I want to do next. Well, let's use reciprocals. So if we have the value of sine, the reciprocal of sine is cosecant. So without even really looking at the triangle, if we're confident about our answer for sine, then we could just take this and flip it. Put the reciprocal for the value of cosecant. And same thing here. So if cosine is square root of 57 over 11, then secant is the reciprocal function. So that'll be 11 over the square root of 57. And I'm not going to worry about rationalizing denominators in this video. On exams, when you're writing your answers, it's fine with me if you leave radicals in the denominator. In my math lab, you may have to multiply top and bottom by the square root of 57 here. Last values, though. So tangent of B is opposite over adjacent. Oops, that's the OA part of SOHCAHTOA. So opposite of B, that's 8. Over adjacent to B, that's that square root of 57 side. And then cotangent is just the reciprocal of that. So we could just take that value and flip it. Square root of 57 over 8. And we're done. Those reciprocal identities can really save you some time, and they're very much worth memorizing.